Hey guys, it's Mr. Fourth Dimension, and we're working on the push reset. So I'm gonna catch you up on what I've done since last time. The last problem that I said we were gonna work on, or that I was gonna work on, is fixing the entity freeing situation, so that we can properly free an entity and reuse it later. That is now in existence. We can now free an entity. What I went with was I just decided to make an array that's gonna have at least enough space to hold one ID for every entity that exists. And then when an entity gets freed, it puts its ID on this list and increases the count. And then next time you allocate something, instead of always taking off the front of this, it'll first try to reuse these. Now, the disadvantage to this is that means that there's little gaps throughout the entities that are not real entities. So when you're looping over them, you have to skip some of them. Let me show you what I mean by that. Well, first of all, up here when you add an entity, first it looks to see if the free count is 0. If it is, it grabs a new entity that exists. Technically this asserts, now that I look at it, should go in here. Otherwise it grabs one of the free entity spaces to allocate that new entity. And the other thing that happens is the free entity. Oh, skipped it, right? So here it sets the type to error. And I don't know if that's the right thing. Maybe I should rename error to like freed or non-existent or something, because it's not technically an error anymore. But basically, when it's looping over the entities to do things like moving them and drawing them, it only processes them if their type is not error, right? So we have to say skip this if it's not a real entity type. And that means that there's a little bit of inefficiency there. It'd technically be more efficient if we were not iterating over things that weren't free. Like you could imagine that when you free something, you don't put it into a free list here, you just say grab the one at the end and fill in the gap there. The problem is I don't know if maybe I want to be able to have IDs be stable. Right, if I have an ID to an entity, I might want to be able to use that ID to look it up. So even if I did, take out the gaps here, I would still need something like this. It wouldn't be for the list of free entities, but it would be the mapping from ID to location here, because then IDs wouldn't be enough to get to here. And that would entail like another dereference every time we're trying to find an entity. We would have to have its ID, look up its position here, and then look up the entity here, rather than just have its ID, look up the entity here. So I'm not sure which way would be better right now. It might also be the case that we just don't need to store the IDs permanently, and that the concept of calling it an ID is just wrong, because maybe it's not an ID. Maybe the ID does exist, but we very rarely need to look it up by ID, so that double dereferencing wouldn't be a problem. Something like that might be true. So, yeah, it's not clear yet that this is the best solution, but right now it's a very easy solution and it's working. And since we have so few entities in this game, and since the system is it is fairly straightforward, this is just not that much memory, if I remember correctly. It does mean that every entity now costs 2 bytes here. The entity size here, I believe, is currently 15, but if we say that that's 16, like I've been shooting for, and we have 360 of those, and we also have 360 times 2 more for this here, then that's still just this many bytes to store all of the game critical data, like all of the information about entities in the game. So it's taking 6 kilobytes to know what everything in the game possibly contains. So that's not quite true, because there's also the grids, so that's another 360. And a grid cell's gotten kind of big because it contains 6 of these and a count. So how big is a grid cell? A grid cell is 6 times 2 plus 4 more. So a grid cell is also 16. So we really have 16 plus 2 per every grid square in the entire game worth of memory. And again, the grid's got to be 360 because that's the size of the grid. So if we shrink the grid, that wouldn't change. And like the entities doesn't necessarily need to be 360, and this doesn't necessarily. So these can all be shrunk. But right now, what we're dealing with is 34 bytes times 360. So it's up there a little bit. It's about 10 kilobytes. But to put that into a reasonable perspective, let's look at Emacs itself. Emacs is using 18,000 kilobytes just to edit this file, right? OBS taking 200, like this is in megabytes. Nothing, 10 kilobytes is nothing, right? It's fine. Let me get the calculator back. Didn't mean to close it. Okay, so point is that's what it's currently doing. So the only real concern I have with that is the gaps, which is kind of annoying. Space isn't really the issue there. The other things that I've done, I added ice. I don't know why I have a blank to do here for. Whoops, that's not what was supposed to happen. There we go. So I have ice, which I've added. You can see ice right here. And the way ice works isn't too hard to explain, so I'll do that. First of all, you have this section here, which is step 2, when everything generates its, the first part of step 2, where everything that has some sort of inherent motion generates its motion. So that means the player, first of all, looks to see if he's on ice. So we have this function called cell contains ice. So once we get the cell that the player is in, we pass it to this function, and cell contains ice is a very simple concept. It just loops through everything in the cell and sees if any of them are ice, right? So loop everything in the cell. If the type is ice, then it has ice, and return that it has ice. If it has ice, then the player pushes in the direction he's already facing, right? Otherwise, he pushes in the direction that the player has, the keyboard input from the player. Now, we also have to loop over all of the entities now. And what we are doing here is we're saying, look, is this entity on ice? First of all, if it's flying, it's never on ice, so only check to see, only ever set the ice to true if it's not flying. And then if it is not flying, grab its cell and see if it contains ice. If it is, then it is actually on ice. Anything that's on ice moves in the direction it was already moving, and right now it currently does nothing because we don't have any entities that have a usual rule. Now, one thing we should do is I should combine this with this. This shouldn't start at 2, this should include the player, and the player's usual rule is just this, move in the direction of the input. Right, so this part here is going to be sort of a switch on type, and if it's the type is player, it does this, and then we can collapse this and this into one. Like, this code just won't need to exist, because it'll just be handled by this loop. But I'm currently not doing that because I just didn't feel like it. I'm going to take care of that right now, because it's all set and ready to go. No point in delaying anymore. It's a switch on the type. If that type is player, then we follow this rule. Right, and then we don't need any of this. And then just set this to 1. Okay. So that should be good. So that's how we get everyone to generate their movements. And then you go through the entire queue of pushes, because you just generated at least one for the player's movement, and possibly a few more for solids or for the player slipping on ice. You generate all these pushes that need to occur to move things along. And then the next thing that happens is a little different, is when you see that you're hitting a solid, first you still apply the same rule to the solid. If it's a player, and we're not just going off the edge of the screen, then you apply the push block rule. There's also this clone rule that we're going to get into. But either way, you apply one of these 2 rules, and then you see if you're on ice. If you're flying, again, you're never on ice when you're flying, so only check this if you're not flying. And if you're not flying, grab your cell, ask if there's any ice in there, and then store that in here. So now, if this entity is on ice, then it should be slipping, and therefore, the fact that it hit a solid means it should bounce and go the other way. So whatever entity was slipping on ice is now going to compute the reverse direction of the direction it was moving in, and it's going to push into the other queue to be processed again, the fact that it wants to slip that way, right? It wants to slip in the reverse direction instead of the direction it was slipping in. And there's also this, hold on, computes its reverse direction. I don't think I'm actually handling the case of, oh, here it is. Okay, so if the reverse does not equal the current direction. So what this is saying is, look, he's already moving in some current direction. So we have this push that when afterwards, if we haven't set push.dir to stop, then the next dir is going to be whatever this dir was, right? So what we're saying is we hit a solid moving this way, right? We're trying to move in a certain direction, we hit a solid. Reverse it. If that reverses the direction we were already moving in, then don't do this next step. So if, in other words, if the reverse version is not the direction we were moving in originally at the beginning of this frame, when we first hit a solid, because it's possible that you hit a solid moving one way, bounce in the other direction, and hit another solid that direction, and then it's going to try to reverse you back. So if it does reverse you back, it's going to see that the new reverse direction is the same as the old direction, and in that case, it's going to skip this. It's not going to keep on bouncing you back and forth infinitely. It's going to say, you know what? I bounce forward, I bounce back again, and there's still a solid in the way, both directions, so just move me in the way I would have moved if there wasn't a solid. If I end up inside a solid and I die, that's just what the rules say should happen. That's one of the little holes in the logic of this. You know, you could set this up to go either way, that you never reverse twice or whatever, but the logic I'm going with here is you keep on reversing until you are going the same direction you started in, and that has to prevent you from... There's only a finite number of directions to move in, so eventually this will prevent you from, like, getting into a cycle, in theory. Now, it might not forever, because it might cause you to bounce back and forth between two directions that aren't the direction you're facing in, but right now, the only way you can bounce, in the ice rule anyway, is you can either bounce the way you were moving or the opposite way. You can only reverse. And anyway, afterwards, all that is done, it sets the next direction. So, if, for example, this part never happens, right, then the way it ends up moving in the direction of the solid is that this push still gets applied, because we didn't stop this push from working. And if we did hit a solid and we did decide to reverse this, then this setting this next dir is going to happen again, it's going to be replaced. So it won't move us that way. So you've already seen this, then we move all the entities, you've seen this, and then the kill rules, they haven't really changed. This is a new kill rule that raises a small problem, but not really a big deal. Kill everything, you're familiar with that. Alright, cool, so I'm going to show you how this stuff works first. Then I'm going to show you the cool little experiment I did with the clones. So, first of all, they're slipping on ice. I have to press space to make the ice slipping work, or I can press up, down. Anything I do, basically no time ticks happen unless I use one of the inputs. Right, and once I use an input, it does a time tick. So that's a problem to solve. When the player is slipping on ice, the time tick should be automatic. Now, this is more correct, because I'm not slipping on ice, so the blocks wait until I step to keep slipping. Now if I move down, now you can see that the block is slipping along as I move. Right, and there you go. So that's working. Then there's, of course, me bouncing off the wall, which will work. Boom, and it pushes him, which it's supposed to do. There's also the matter of, what if there's a block behind it? Does that work, right? You want to check all the combinations. And then eventually you just kind of use the idea that they're all going to keep working, because the thing that causes this push block to push when I hit it now isn't any different than it ever has been. So that should still work the same way it did when I was pushing it normally, unless there's an unforeseen bug. And then, of course, there's the matter of what happens when I push this push block, right? And it's going to move along and bounce. And the reason it doesn't push that is because if you look at the code, it only ever considers pushing a push block, or in any solid for that matter, when the pusher is the player. Now maybe what's going to happen is we're going to replace this with a sort of entity can push, right? If something is a push, it has the power to push, then it applies this. So maybe other things have the power to push. That would be neat. But there's one last little thing we should do, and to show you this concept I have to go and add another block of ice. I want to show you the idea of bouncing between two solids. Where is the add ice stuff? Here it is. So right here we're going to add another piece of ice at position number 10, just temporarily. Alright, so I push this one that way, that'll make a nice wall over there, right, and when I push him he bounces off like that, and then I take one more solid that I want to place right here for now. Now what I'm going to do is push him, and I'm going to push this one down. Now he's going to come up and he's right here. Now if I stay where I am by pressing space, I get crushed by that block. What happens if I move to the left? Okay, so now we've stepped one frame, and since I'm freezing on ice still, we have a moment to investigate what's going on. So what's happening here? The player is still slipping on ice, so he's going to try to keep moving forward no matter what I do, and he's going to hit that push block. But when he does, first of all, that push block is going to end up moving to the dark spot next to it, and the player is going to try to reverse into the block to his right. And when he reverses to the block to his right, he's going to push that block, and then he's going to reverse back. At least that's what I think is supposed to happen. When he reverses back, he'll decide, okay, even though there's a solid in the way, I'm going to move to the left. And so he'll move to the left, and he won't actually get crushed because the push block's actually going to move on the same frame and be fine. He moves to the right instead of to the left. That means he reversed once. Interesting. Let's take a look at why he would do that. Maybe it makes more sense than what I said would happen when I look at the logic again. So, yeah, so the next dir gets set by the push that we're currently processing. And we should be processing the original one, which was caused by him slipping on ice. And it gets reversed once. And then on the next step through, he processes that one. He should still see that he's... Okay, so right then and there he sees, okay, if I reverse again... He's saying if I reverse again, I'm going to be back into my original direction. So what we want to do is we want to say, if I am reversing back to my original direction, don't process that as a separate push. Just set this push to do that. Might seem weird, but the logic here is the current push is not the reversed one, right? This is the one facing to the right. And we've checked that the next one forward, if we reverse again, is that going to push us back in the same direction? If so, skip it, right? But if we're skipping it, then we're never actually going to have a push us that way, which is what we want to do. So, since we know we're definitely going in that direction, this code right here has just decided, don't do this, we're definitely going to move in this direction. So stop processing the queue, but also make sure that we set this thing to push us the right way, because it was going to push us the opposite way from what we expected. That should cause them to move to the left when we do the same experiment again. Boom. Boom. There we go. He comes up, and we move to the left as expected. Very cool. Now there's one other thing we should look at, which is kind of important. Whoops, that's not what I meant to do. Boom. Okay, so what's to stop me from pushing it down right now? Let me show. I push down, nothing happens. So why didn't something happen? Well, I have a little hook in the logic, which is something I want to change in the future. But the push block logic now says when you're pushing onto a block, check that he's not on ice already. If he's not on ice, then push him. Why would I want that? Well, it turns out that if we don't do this, we can get weird rules in terms of who happens first and whatnot. So there's got to be a hierarchy on which pushes overrule other ones based on what their sources were. So slipping on ice overrules the player pushing into you. And I'm thinking what we want is we want pushes themselves to know that we want to encode this not just in terms of it, but literally encode that as an integer here, and then in the in this entity. So one thing that's probably going to happen is this is going to become a bit field, because we're going to have solid, floor, flying, can push, and we're going to be out of bytes. So that'll become 1 byte, right? And then we'll have another byte that measures what is the it'll go along with nextdir here, which nextdir is used for processing movement, right? We'll have another one that'll be something like push priority, right? And this will record the most important push that has happened to this entity yet. And every time you move, we set the nextdir. If I search for it, yeah, nextdir gets set to stop. The push priority would get set to 0 again, and then like if you're pushed because you're slipping on ice, that priority would get set super high, and nothing would be able to overrule that. So even if a push got processed, it would get ignored because of the fact that the priority was lower. That way, we don't have to have if logic for every single exception when we start adding more and more complicated rules of you can't push something that's slipping on ice, you can't push something that's moving because of this reason. Something that's moving because of this reason can get pushed unless it's slipping on ice, right? Things get weird. So it's just easier to have that encoded somehow, but right now this is simpler than a complicated system. And if this turns out to be the only case, then maybe we don't need that. But that's just a thought. Okay, so now let's talk about the clones, because this was really cool. I just felt like seeing how flexible the system was, seeing if it was actually robust against new ideas. So this is not in the original game. This is the first new idea that I've thrown in here. And what happens here is it's playing the same rule sort of idea as a block, in that it's solid, and when you push into it, something happens. It responds. But instead of simply responding by enqueuing a new push to process, the absorbing that, it's still the idea that the solid thing has absorbed the player's motion, but now it's going to respond differently because of that absorption. So what does this do? First it says, make sure I'm not on ice, because he also follows the rule that you can't do anything to him while he's slipping on ice. Then we find out if this is, there's basically two cases, the up and right or the down and left, right? So if the player is pushing up and right, then this clone is going to do, if it's doing up or right, then this player will do up and right, right? And if this player is not doing either of these, then he must be doing left or right, or left or down, so it becomes vertical of down and horizontal of left. Then what we do is, they're currently named up and right, but those should be like V cell and H cell. Right, so the vertical cell and the horizontal cell, we grab both of them using the vertical and horizontal directions. And then if those are both valid, so what's going to happen, the rule here is both cells have to have space. If either of them is solid, or if either of them goes off the edge, then there's no space there. So first of all, both cells need to be valid. If either of them is null, then it went off the grid. And then it says get a solid, or okay, so cell get solid is another function. It's similar to cell get, or cell contains ice. Let me pull it up real quick. Get solid. And I pulled this out because it used to be, this loop right here was right inside the motion rule right here. And I pulled it out because I was going to need it for this rule too. So basically this says, go through the entire cell that I provide and see if any of them are solid. If so, return the ID. And I have a to-do here that says, if there's two solids in this block, I probably don't just want one of them. I probably want a way to get both of them. And the reason for that is technically it's possible for two push blocks, or a clone and a push block, or weird combinations like this, to both be in the same cell. It's hard to construct situations where they actually end up in the same cell and they're not slipping on ice, but it is possible, and I could show that. And once they're both on the same cell, I'd like to be able to, like, when the player pushes on one of them, they should both absorb it, not just one of them, because that's just more logical. Otherwise, if they don't both absorb it, then which one absorbs it, right? If they're different, if they're both push blocks, then it doesn't matter, but if one of them is a push block, one of them is a clone, it very much matters. And the truth is, the rule should just be, it doesn't matter, they all absorb it. So if you have like a push block and a wall, which you can't have because walls have higher kill power and kill the push block, but if you did, it both would get absorbed, and the push block would move, but the wall would not. And the fact that the walls don't kill push blocks doesn't mean you can't have something exactly like a wall that doesn't kill a push block that could have that interesting property, if we so wanted to do something like that. But let's focus back on the issue of the clone. So after getting both cells, if both cells exist, it checks to make sure neither of them have a solid. If neither of them have a solid, what it does is it actually first creates a new clone at the same location as the old one, and then both clones get pushed. One of them, the original clone, gets pushed horizontally. It doesn't matter which is which, right? We could switch them, and the logic would be the same. Like, the results would be the same, which is kind of interesting. But the clone gets pushed along the vertical direction, whether that's up or down, and the other one gets pushed along the horizontal direction. And this is just me implementing the pebbling the chessboard rule. I don't know any other names for it, but why is that? Oh, this should be the V cell and the H cell both need to have no solids. And that's equals 0 because it returns the ID of the solid. So if that solid has an ID of 0, remember there's no entity at 0. That's specially reserved. So that's basically like not a actual thing. So let me push on this and show you what happens. I'm going to push up. You can see he splits up into an up and a right. I'm going to push to the right on this one, to the right of me, right here. I'm going to push it to the right. Same thing happens. It's split up and to the right. Now I'm going to try to push up on this one. Doesn't work because it's got a solid in the way, right? There's a solid. This green right here is a solid, so it won't move up when I do that. I can, however, push it down, and it'll go down and to the left. So that's different from the normal pedaling the chessboard. Normally you can't go backwards like that. But I thought it was cooler that I could go either direction. So I can push this to the left, and it'll do that. Then I can push it to the right and extend this all the way out. And you see I'm just applying this rule, and it creates this like wall, which is kind of neat. Then I push up, and I create this wall here. And it also works as you would expect on ice, because it's just, the way that it's moving is it's just putting them both on the same square, the same spot, and then pushing them out from that position, right? So it's already only doing that if there's space to do it, but it could be that there's space to do it, but that the ice, you know, is there, and so it'll keep slipping, like normal solids would. So this means we can do all sorts of fun stuff. Like this was just sort of a proof of concept to make sure the engine was really solid and easy to add new concepts. Of course, it is fun to play with. I also went and made it annihilate with pits, right, to fill pits in, like push blocks do. And that leads to a small problem. The problem that I discovered because of that is that even with the kill power, we're going to have a lot of this nastiness going on, where, you know, like the pit has a rule when it hits a block and when it hits a clone, and these are like annihilation rules. So there's a couple ideas I have. One thing we could have is just annihilation rule. This would be maybe like a table or a hash table where you could look up a pair of, you know, a pair of two types and see if they annihilate or not. Problem with that is there's a lot of types. Like I said, it would have to be a hash table maybe, so that we weren't actually storing one for every pair of types, or like a 1 or a 0 for every pair of types, but we would just store, is this pair in the hash table? If it is, they annihilate. That's one idea. Another idea I had is that maybe the pits just need a special rule. Like, it's not just a matter of if these two types, but it's maybe more a matter of if entity 1 type is a pit, then the pit just has a rule that it always applies. If the entity 2 is solid, then kill both, right? So this is a nice way to clean up both of them. And this is what I'm doing for now, just because it sounds to me like it's correct. Like, that's what the pit should always do. And that's just a nice, very simple, obvious rule that makes it work. Now, there's certain things where it's like, is that what is right when you have things from later in the game, like pushable wires? We talked before about what happens when a pushable wire fills in a pit. Does it stay wire, or does it just become ground? And this rule would say it just becomes flat ground. Right? Which maybe that's right, because this rule is very simple. This is the tight rule of what the pit does, is it turns solids into floor. But it's also kind of weird to say that a solid can have an additional property that doesn't have anything to do with its solidness or its pushability, right? It's not about what kind of object it is in the whole movement scheme, it's about its conductivity properties. Maybe floors should have a conductivity property, and that when you do this, you create a floor that has all the same properties as the solid does, except for a few things like it's a floor now, it's not flying if it was flying. But then again, a flying solid wouldn't fall in the pit. So that's another thing to think about, is this shouldn't even apply if we have such a thing as a flying solid. But yeah, I'm going to go with that for now because that does work, and it's the simple way to get pits working. And I don't think that other things like you know, when we add baddies, for example, they are going to annihilate with ghosts, like the bats and the beetles. If you've played the game, if you've played the game, bats and beetles annihilate with ghosts. So this would be another case where it's just like, if, you know, type. This is obviously not correct because I'm just giving an example. But if the type is ghost, and if the other guy is baddie, right, then, or is alive, is kind of the concept, but, anyway. What I'd like to do now, we got some, now that I've recapped everything, is I'd like to take another quick moment to talk about this. So, motion input, this to do here, sliding on ice without player input. So right now, as we talked about, when I walk on ice, I just stop. Unless I hit any input will cause me to keep moving, but I have to keep pressing inputs, which the original game had this all worked out that if you're on ice, you slip anyway. So, how does that work out? Basically, after computing all this, right, what we got to do is we got to say, look, this motion input should behave totally differently if the player is on ice. So, the way we're going to do this is going to be pretty simple now that I think about it. Grid cell equals get, oh wait, let's get the player entity player is get the entities array, add 1 because the player is always at that location right now, get his cell, grid cell, the player's position, and then we say if cell contains ice, cell, put a not there so we can put the normal case first, then do all this logic that we applied before. If, however, it does contain ice, then motion input equals 1. Now this isn't going to be quite right because the frame rate, like, you don't want him to move every single frame of the game. That needs a vars. You don't want him to move every single frame of the game because it's just too fast. I'll show you what I mean. Right? He just zips. So we need to put in like a timer situation here. That if he's on ice, then start ticking like an ice timer and move him forward when that hits a certain value. The other thing I want to do real quick is I want to check that we're actually even applying a frame rate. 'Cause I can't remember if I ever actually did. So let me just pop over here into this code. It's like a sleep situation. Okay. And milliseconds per frame. Milliseconds per frame. Looks like we set the update hertz to 30. So that should be correct. I'll take more time to look into that, but I don't really want to go into the whole Windows layer, the platform layer that runs this engine. So if you want to see how I did set it up, it's pretty similar to Casey Muratori's, and so it's better that you go and look at his system for that. It's not a handmade hero. Okay, sliding on ice. What we need here is the app vars to have a ice player ice tick timer or something like this, right? So push game right here. Ice. I don't think I need T anymore. Ice tick. Let me see if that causes it to stop working. Good. That can go away. Now, if we do this correctly, it won't be too complicated. So the ice tick will start at 0 because of this. So we can assume the first time we start slipping on ice that it's at 0. So if we just make sure that it's always at 0 when we stop slipping on ice, then we're good. So here's how it's going to work. Ice, or vars, ice, tick, gets incremented. If that amount equals, let's set it to 5. Let's see if that's good. If we've waited for 5 frames, set it back to 0 and update the movement. Now if that moves us off ice, it'll stay at 0. Otherwise, it will repeat the incrementing process. Yeah, so he's slipping along. It's actually a little slow. And then that means that we want to lower this. Now, another cool thing that happens is in the game it keeps track of how many turns it takes. And a little tip, if you're optimizing ice levels, it only counts as 1 turn to slip on ice. Even though time ticks more than once, I only count that as 1 player move because I thought it was more interesting to try to maximize your time spent slipping on ice if that meant you could, you know, have fewer turns in the level. So one optimization technique is to try to get as much distance as you can on ice. So that means that the way we count time ticks is going to be based on this code here, the this versus this, nothing that actually happens in here. Because if we counted how many times a motion input actually happens, that it counts the times when we're slipping on ice, and we only want to count times up here. So anyway, that takes care of this to do. Moving forward, I'm probably going to deal with adding in the electricity and the bugs stuff. I can't think of any other things that I really need to get in to re-accomplish the original engine. So yeah, that's what I'm going to be doing. I'm not sure how much I'll get on video, but maybe it'll be some of it, maybe it'll be interesting, or maybe I'll just show it to you afterwards, like I have been apparently. Anyway, hope this has been interesting. See you guys next time.